Good morning, class. Today we are looking at perpendicular bisectors. Specifically, we're looking at the perpendicular bisectors of a triangle on the sides of a triangle. So your essential question, how do I apply the properties of perpendicular bisectors? Your learning intention, I'm learning to construct perpendicular bisectors and use the characteristics of circumcenters to solve problems. So, you've got 3 warm-up questions. The first 2 deal with the Pythagorean theorem. If you don't remember, that's a squared plus b squared equals c squared on a right triangle. The second is about an isosceles triangle. You have to know what the word isosceles means. What does it mean? 2 equal sides. 2 sides that are the same length. So, pause the video now and see if you can do the warm-up questions on your own. I hope you tried. You'll never know how much you're understanding if you don't try the warm-up questions on your own. So if we're looking at the Pythagorean theorem, a squared plus b squared equals c squared. So we know a and b on this triangle, and we're looking for c. C is the longest one. It's a hypotenuse. The hypotenuse is straight across from the right angle. 8 squared plus 15 squared is equal to c squared. I'm going to use c instead of a just because I feel more comfortable with it. What is the opposite of squaring? What undoes squaring? Square rooting. Now, I can do this all in one step by using the calculator. So, to find my square root button, I hit second and then I come down here to this x squared and I hit it, and I've got the square root. 8 squared plus 15 squared. Close it off, hit enter, and you get 17. 17 is equal to c. Okay, so when you knew the sides, you added. If you know the hypotenuse and one side, what do? You subtract. So in this case, it's going to be 15 squared minus 9 squared is equal to e squared. What is the opposite of squaring? Square rooting. Once again, we can do this all at once. The square root of 15 squared minus 9 squared. Close it off. And you get 12. So, 12 is equal to e. So this is an 8, 15, 17 right triangle. This is a 9, 12, 15 right triangle. So looking at the isosceles triangles, if we have to have 2 equal sides, what do we know about these 2 expressions? Well, they have to be equal also. 2x plus 9 is equal to 5x minus 6. When we get ready to solve equations, we need to always draw that line through our equal sign, draw a line underneath, and keep our column straight. let's start with our variable, which is bigger, 2x or 5x. 5x is bigger, which means we will subtract 2x from both sides. 2x minus 2x is 0. I've gotten rid of it over here. I'm left with 9 is equal to 5x minus 2x is 3x. Bring down the minus 6. Once again, draw those lines. I need to get all the numbers to the same side of my equal sign. 3 times x minus 6. The opposite of subtracting 6 is to add 6. 9 plus 6 is 15. 15 is equal to 3x. Hopefully at this point you know what x is because you're going to divide both sides by 3. And x is equal to 5. How do I check? Okay, 2 times 5 plus 9. 2 times 5 is 10. 10 plus 9 is 19. 5 times 5 is 25. Minus 6 is 19 also. So you substitute in and make sure both of those numbers are the same. Okay, that's all of the warm-ups. Now we're going to look at today's lesson. Remember, when we're looking at geometry, we always have to be able to understand the definition. So if we're looking at the perpendicular bisector of a side of a triangle, what is it? What does perpendicular mean? Perpendicular means it forms a right angle. Okay, so if we want the definition for the side of a triangle, it's a line perpendicular to the side of a triangle at its midpoint. Okay, and what is the midpoint? Exactly what it sounds like. It's a point in the middle. Okay, so we've worked with perpendicular bisectors before. Think of some of the theorems we've used, especially the one called the perpendicular bisector theorem. So that's the way your thought process should be. So next is the circumcenter of a triangle. What is the circumcenter of a triangle? It is the point of concurrency Okay, concurrency comes from the word concurrent, which means at the same place or at the same time. The point of concurrency of the three perpendicular bisectors of a triangle. Okay, the upside down T is our symbol for perpendicular. Okay, there's a couple more things we need to know what it means. A circle that contains all the vertices of a polygon is blank about the polygon, and it's called the what? Okay, so if it contains all those points, it is what we call circumscribed. So if it's circumscribed about the polygon, what would it be called? What kind of a circle would it be? Think logically. Well, circumscribed circle. Okay, so now we need to do some thinking. What are some important characteristics of the circumcenter of a triangle? Remember, it's a point of concurrency on a perpendicular bisector. Okay, what is the perpendicular bisector theorem? Okay, it states that any point on the perpendicular bisector is equidistant from the endpoints. So if it is equidistant from the endpoints, what do you think that circumcenter of the triangle is going to be? If you said equidistant from all of the vertices, you would be right. Okay, it's an important thing to remember because, once again, this is what we call an invariant. Invariant means something that will never, ever, ever change. So, if this point P is a circumcenter, what do I know about these two pieces here? Well, if P is equidistant from every vertice, then those two pieces have got to be the same length. So we can solve by setting it up equal to each other. 7x plus 15 is equal to 10x minus 9. Draw your lines. Think, which is bigger, 7x or 10x? 10x is bigger, so I'll subtract 7x from both sides. 7x minus 7x is 0. I've gotten rid of it on that side. 15 is equal to 10 minus 7 is 3. 3x minus 9. I've got to get my numbers to the same side. I've subtracted 9. The opposite is to add 9 to both sides. 15 plus 9 is 24, is equal to 3x. Divide by 3, and 8 is equal to x. Okay, how do I check? Well, let's put it in here. 7 times 8 plus 15. So, 7 times 8 plus 15 is 71. 10 times 8 is 80. 80 minus 9 is also 71. So I know that I have worked the problem correctly. Okay, now, that's how we do it algebraically. How do we do it by drawing? Do you remember how to draw the perpendicular bisector of all three of the sides? Do you remember how to do a perpendicular bisector? Well, the idea is to make it equidistant. So what I'm going to do, I'm going to make sure that my compass is over halfway the length of the side. So I will make an arc up above, and then I'll make an arc down below. From the other side, once again, an arc up above, and an arc down below. Now, because I have not changed the distance, then I know these 2 points are the same distance from that edge. Now I draw a line. So I'm going to start about right here and draw my line here. There's my first perpendicular bisector. And I repeat this process for each of the edges. So if I am on this edge, I could actually make it a little bit smaller. Well, I think I'll make it a little bit bigger because I don't want to go through the middle of my triangle with that arc. Remember, it doesn't matter how big your arc is as long as you do not change the distance. It's okay if I go out into the edge there where I'm writing my notes. It's not okay if I go through the middle of my triangle because it will make it messy. Okay, now come over here, get this edge. Oh, what did I do wrong up here? I didn't make my arc long enough. In fact, I didn't make it from either side long enough. So here we go. I'm going to come this way. Here it is. And I'm going to come down here and get that other arc so I know where my point of intersection is. Good thing I have an eraser, huh? Wouldn't have to erase it, but it does make it look a little bit nicer. Okay, once again, I look at those 2 points of intersection.